Alright, so what did we do yesterday? We learned more about lists and how they function, and we compared them to tuples and how they function. Yeah. Both kind of restrictive, but in their own kind of way, I guess. Right, and we learned that we can zip them together like this and create something that looks very much like a Python dictionary, doesn't it? And then I got scared because I saw maths, and I was like, oh no, I don't want to do maths. Colgatino says, I used unnecessarily long variable names that were non-descriptive. Oh yeah. We ripped it up, your test, because of that. One way of doing things, I guess. Alright. So, let's check this math thing and see how important this bit was. Here's a problem that combines tuples and list comprehensions. Right, we learned about list comprehensions. That was the most time we spent yesterday. Yeah, this is a list comprehension. Indeed. Alright, so here's a problem that combines tuples and list comprehensions. Which right triangle that has integers for all sides and all sides equal to... Oh, man. Alright, first let's try generating all triangles with sides equal to or smaller than 10. Alright. Alright, we have integers for all sides, so there are no floats. Alright, so we generate... Yeah. These are lists, and we do a list comprehension, right? So we can make comparisons. Because these are now 3 lists with that contains 1 to 10. Yeah. Aaron Zero says, well, he had a reason not to like them. Yeah, tearing them up. Indeed, Aaron Zero. Names are hard, I think. Colgatino says, yeah, I was... starting, so I hadn't grasped the concept of readable code yet. I've kind of grasped it. I'm not good at it, but I've understood why it's important. Alright, so yeah, we can do this actually. We can do it in here, yeah. We just do this whole thing. Alright, triangles. I still don't know why we have to use let in the interactive Haskell. Yeah, this is interactive Haskell. Right, let triangles be equal to... Right. And then we make a list of tuples. Wait, no. We make a... Alright, this is so confusing. We make... list comprehensions. This is a list, but it contains... We take A, B, C, right? This is a tuple. Oh, right. So the first one is going to be... The list is going to look like this. 1, 1, 1, 1, 1, 2, 1, 1, 3, and all the way up to 9, 9, 9. Yeah, this is what the list comprehension is going to look like. Right. Oh. Is it the other way around because we start with C here? Will it be... I'm not 100% sure what order things are going to be done in, but you get my point. This is what we're doing. Whoops. And last but not least... Maybe it increases A first because we put A last here. I don't remember. Is it important? It's not really important since we fill it out completely. Right. Yeah, 10, 10, 10. Oh, yeah. 10, 10, 10. Not 9, 9, 9. I was... You get my point. Yeah, we got a list of tuples. Oh, and these are all the possible triangles, right? Yeah. These are all possible triangles with sides that have integers that are smaller than 10? Equal to or smaller than 10. Indeed. All the triangles. Got a list of all the triangles. Node owner says Derek Mueller's newest video is pretty good, although math heavy. I mean, I can enjoy watching math heavy videos because I don't have to do the math. I'm terrible with names. I feel like you have recommended Derek Mueller before. Is he German? Wait, isn't this... Wait, recent news. That wasn't YouTube. Alright, let's go to YouTube. And what was it, Derek? Derek Mueller. Oh, it's Veritasium is Derek. Is his last name... Wait. Is he really Derek Mueller? Is that his name? Yeah, Derek Mueller is the Canadian host of Veritasium. I didn't even know he was Canadian. Right. I still haven't caught up on Veritasium, so I'm looking forward to it. Yeah, his videos are math heavy, but I still enjoy them, which is great. I don't have to do any math. Well, Get In on Tap says, my teacher was delighted when I grasped it during our final projects for that course, and even made a Facebook post about it. Made a Facebook post about your test? That's kinda fucked up, isn't it? Aaron Zero says, that teacher is extreme sides display both disappointment and appraisal. Good point, yeah. I mean, if you're gonna be extreme on the disappointment, it's a good thing to be extreme on the appraisals as well. Maybe that is a good teaching thing to do. Being extreme like that. Just knocking some sense into the kids. Alright, what is a perimeter? Is that A plus B plus C? Or is it... I guess we don't have to know math. He's gonna tell us. Right, we're just drawing from from 3 lists, and our output function is combining them into a triple. Yep. Triple. This is a triple, yeah. Right, just to reiterate, well, it kind of, I like this. The list comprehensions in Haskell are super straightforward, right? We make a list, and the list has this format, right? This is the content of our list. This is what it looks like. And then we say, this is what C is, this is what B is, and this is what A is. Straightforward indeed. If you evaluate that by typing triangles, that's what we did, you'll get a list of all possible triangles with sides under or equal to 10. Indeed. Next, we'll add a condition that they have to be right triangles. How do we add that? I'm assuming this is the right triangle when you get a 90-degree angle. Is that a right triangle? We'll also modify this function by taking into consideration that side B isn't larger than the hypotenuse. Oh, yeah. C can't be bigger than B then. Wait. That side isn't larger than side B. Alright, let's try this again. It seems like we're just... Oh, yeah. That right triangles. So we take the same, but we change the name into... oops. Right triangles. ABC, and we do the same thing, but just after doing all of this, we add a condition. No? Predicate. They called it a predicate, right? That's what we're adding now, predicates? Yes. Oh, right, and then we just add, well, like this. Right. Oops. Plus. Oh, I like that this works. Oops, not like that. Oops, B2 has to be equal to... And that's it, right? That's all of it. Oops. Damn it. Yeah, that... Now we made it to right triangles. Aaron Sarah says, that video, risking my life to solve a physics debate, I find to be severely lacking in mathematical proof and scientific logic. It's the one where he's... where is it? Yeah, this one. Yeah, it was more... that was more an entertainment video, right? Entertainment. And I mean, it's just the one experiment, right? I don't remember. It was a long time ago I saw it. 5 months ago, even. Ooh. Colgate Innotab says, teacher on more advanced groups hit one person with a half-empty bottle and yelled, learn. I'm glad I was in the noob group. That's not really helpful, is it? Right, we fixed the right triangles. So we call right triangles. Wait, is that all of them? Right, I gotta know. Right triangle. Yeah, exactly. With the 90-degree angle. That's the right triangle. And that's all of them? That's not very many of them at all. Outowner says, I use let in Nix all the time. What does it do? Right. What is the difference between... Because I tried it, right? I tried doing this. We had this here, let right triangles. But if we do just right triangles... I think this... Yeah. And then we call it again. There's no difference. It bothers me that we've started using let, but they haven't really described why. He said we had to do it in GHCI, which is where we are in here. That we had to use let, but we don't have to. Nodowner says, I think he himself doesn't understand what is happening, and that's okay. Even experts disagree. Indeed, yeah. In that video, I liked when they described it as a... with the boat. Yeah, the boat metaphor. That one helped me. That's like Veritasium. He's been a science educator, right? So he's trying to explain things so that we can try to build... We, the viewer, can try to build a grasp of what's going on. He's not trying to do science and maths. He's trying to explain science and maths. That's a big difference, right? Science communicator, they call it. So it makes sense that he doesn't use too much mathematics because, well, people like me, if it was too much mathematics, would just be, oh, well, I don't understand this at all. and then just leave it behind. Aaron Sarah says, if you're dumb, just get smart. Exactly. It's like, if you're homeless, just buy a house. It's not really helpful. Indeed. I like that, Aaron Sarah. Yeah. Just buy a house. Colleague Tab says, I don't know if it's helpful. You know more about teaching than I do. I mean, sometimes a little bit of stress is worthwhile, right? Like, let's say the example of your teacher before, where he ripped your paper up and said, these variable names are horrible, I can't deal with this, and rips it up. He made a point, right? You remember that point to this very day. He made a specific point and wanted you to learn a very specific thing because there was one specific thing that you was not very good at. Hitting someone in the head and saying learn is pointless, right? He's not making a specific point. And it has to, right? Context matters, isn't it? Yeah. NodeOwner says, oh, let is where you define your variables, like let version. Yeah, but why do you have to use the word let? Why not just write version equal? Why do we have to let version be equal? Wait, did someone say this for real? Just buy a house? No, this is a joke, right? Maybe not. I can definitely imagine people saying that, yeah. Sorry, I just got off topic with my own thoughts. Oh, it's fine, Aaron Sarah. Yeah, it's fine. And I felt that it was on topic, Aaron Sarah. Yeah, on topic indeed. Colgate in on tab says constants in case of Haskell. Oh, it's a constant and it is a function if you don't use let. All right, thank you, Colgate in on tab. That's why we just do it like this for now, because, well, we haven't learned about types, data types, and that makes sense, right? You do that in most programming. You hold off on the data types and learn data types later on. Watch the video, please. People need to see this. I mean, I don't know if people need to see this, but sure, we can watch the video. Let's post the music.
If you're home...
Just memeing. If you're homeless, just buy a house. I love that. All right, we're almost done. Now we just modify the function by saying that we want the one where the perimeter, and that is that. Yeah. It's a plus b plus c. That's what I thought. So we just right, and then the convention is to add a single quote or an apostrophe for the specific thing we want to do, and we add another predicate. A plus b plus c is equal to 24, right? Was it? Yeah, 24. And then we call it again with that extra, and there we have them. 8, 6, 10, and 6, 8, 10. No, says, be right back. I'm just gonna go buy a house. No, you misunderstood, NodeRunner. You are not homeless, so therefore you should not buy a home. You should not buy a house, since you're not homeless. Tab says, if you can't afford a house, just rent your second apartment until you can. What do you mean, don't afford a house? That's the joke, isn't it? All right. There we go. Wait. Why did... Why did we not get the same result? And there's our answer. This is a common pattern of functional programming. You take a starting set of solutions and you apply transformations to these solutions and filter them out until you get the right one. All right, I kind of feel that I'm still having trouble grasping the idea of lazy programming. And because in my mind, this function right here iterates over all these lists. And there is nothing lazy about it. How can it go and just bring these out? Oh, that's the difference. Wait, was it because... no. Another one says, let A be A equal to 1, B equal to 2, and A plus B. This is how you would write it in Nix. Is it the same in Haskell? Right. Like Colgate InnoTap said before Node Runner, that let creates a constant in Haskell, otherwise it's a function. And you don't use the semicolon at all. I think you would go for a new line. Yeah. Yeah, I think you would start a new line. Like this. Let's try it though. Yeah, that seems to be working just fine. Oh, wait, can I, is there a, like, can we write type B? No. We still haven't gotten to data types, so I don't know. There is a data type. This might be a function, and this might be a constant. But we don't know that yet. We haven't gotten that far. Oh, T? Is this how you do it? TB. Alright. It's still... I don't understand that thing. But they are the same. They are both functions, though, even though I did use let. Alright, let's start with types. But yeah, it seems that you can... Oh, right, I didn't write the full thing, Node Runner. Sorry. If we take let A equal to 1, B equal to 2, in A plus B, we just get 3. I don't know what the in does. What about if we do... Oh, that's a function, no? Oh, thanks, Aaron Zero. I forgot to change the category. There we go. It works. It does work. Indeed. I completely forgot to change the category. It'll change in a minute. Alright. Now we get started with types. We did a little bit of spoiler and started looking at types, but... Right, and then we start getting to syntax and functions. That sounds fun. Alright, types and type classes. Believe the type? Okay. Previously, we mentioned that Haskell has a static type system. The type of every expression is known at compile time, which leads to safer code. If you write a program where you try to divide a boolean type with some number, it won't even compile. Okay, that's good because it's better to catch such errors at compile time instead of having your program crash. I agree with this. That sounds like a lot of sense, yeah. Everything in Haskell has a type, so the compiler can reason quite a lot about your program before compiling it. Aaron Zero asks, what is Haskell? It's a programming language. It's a functional programming language that we're learning about. Yeah. And right now we're learning about the types within Haskell. Unlike Java or Pascal, Haskell has type inference. Yeah, if we write a number, we don't have to tell Haskell it's a number. It can infer that on its own. So we don't have to explicitly write out the type of our functions and expressions to get things done. Yeah, I remember this. Yeah. We covered some of the basics of Haskell with only a very superficial glance at types. Yeah. However, understanding the type system is very important. It's a very important part of learning Haskell. Yes, right. As we have noticed, we need to look into the types. What makes it special or useful? Asks Aaron Zero. It's a functional language, right? Instead of like regular imperative languages, they are imperative. You give commands to the computer within those languages. In Haskell, you create functions that evaluate to answers. So when we call it a functional language, you can think of it as a function within mathematics, right? You have functions within mathematics, right? Like the thing we did here, for example, this whole thing that we just did, this was just a function that evaluated to this. We didn't tell the computer, do this, do this, do that. Instead, we just made a function that got this as an answer, if that makes sense. Right? We didn't order the computer to calculate anything. We just created a function. Right? Actually, we can go to, if we go to the first page again, where is it starting out? No. Introduction. Right. Purely functional. In imperative languages, you get things done by giving the computer a sequence of tasks and it executes them. When executing them, it can change the state. For instance, you set a variable a to 5 and then you do some stuff and then you set it to something else. Exactly. And Haskell is also lazy. That I still don't quite get that, but it's like instead of iterating through an entire list, we just use the pieces that we need. So something special with Haskell is that you can have an infinite list. That is something that's not really doable in an imperative language. Because you have to create every item in the list in an empirical language, right? While in Haskell, you don't have to. You can just create an infinite list and say that it's infinite, but it's lazy, so it doesn't create the entire list. It just creates the parts of the list that you need when you need it. Colgate InnoTab says, again with the calling of imperative languages regular. I mean, they are regular, right? That's the normal, right? If you go to school or if you like type in on internet and search, all right, learn programming. Right, what will you find? What is this? Right? It's imperative programming. That is what we'll find. That is indeed what we'll find. Aaron Zero says, what about calculations and logical stuff? How do you mean? I'm not... Right, you can have functions in imperative languages like Java, you say. Yeah. you have, it's not the same, right? That is not what we're talking about when we're calling this program functional. I mean, they are functions, but it's not the same, like, it's not functions in that same way. It's more similar to the functions we have in math, right? When you write something in Python, for example, def func name, and then, right, you do this, and then you write do x, and then we do y, and then we return something, right? These are all, this is a function where we give commands to the computer. That's not the same type of function in, as far as I understand Haskell, that instead it's more similar to, yeah, a function like this. Where was it? Yeah, we had a function like this. Like Pythagoras theorem, right? That's a well, no, is that a function? Right, so yeah, it's more like logic indeed. Olgitinotab says, what a dark world we'll live in. Functions don't have side effects. Yeah, exactly. Functions don't have any side effects because they, just like maths, the thing that is one side of the equal sign it's always the same, right? In an imperative language, you can do like this, but all right, I remember that. Right, you can do that in an imperative. Well, sorry. In an imperative language, because we give the command where we say that we set a to 5 and then we set a to 6. That won't work in a functional language because, well, we just said that a is 5. So a cannot be 6 because 6 is not equal to 5. Right? This breaks a functional programming language. Right? They called us a liar. If you do this, you're a liar. Yeah, you are a liar. That was a pretty good educational way of putting it. Yeah, making you a liar. That would be a side effect, yeah. No, says apparently learning programming is equal to JavaScript, right? JavaScript, that's the way to do it. I mean, it's either JavaScript or Python, isn't it? When you first get out, if you just search on the internet, you'll either end up with JavaScript or Python, won't you? Right. JavaScript if you're interested in web development, and Python for everything else, I guess. Aaron Sarah says, wait, no, I mean mathematical functions. You can do that in any language? I suppose you can, yeah. I'm not a mathematician. I'm not very good at these things, but yeah. Colgate says, they teach our children to become liars with imperative languages. Right, exactly. So you never modify variables, only output different values. Yeah, exactly. You have to create a new, right? You would have to, if you want to have a variable that is equal to 6, you would have to do something like this. Right? That's okay, because now we have b is equal to a plus 1, right? B is equal to 6. Yeah. And that's the benefit of it, as I understand it, is that no side effects, there will be less bugging, right? The way you write the code. And that's the benefit of learning Haskell. I remember someone saying that if you learn Haskell and understand a functional programming language, you can bring these some of these good practices with you to your regular programming language, like the immutability of variables, because when you change a variable around here and there all over the place, that very easily leads to problems. where you don't really know what's going on in your program, right? What's my variable right now? I don't know, because I've done so many things to A. So A is not 5 anymore, and it wasn't 5 for a long time. I only learned Java. I haven't tried Java myself. All right, so back to it. Types. We were looking for types. Yeah, went on a tangent, but that's fine. All right. Right, this is type inference. Right, we know that. And can infer that on its own, so we don't have to explicitly write out the types of our functions and expressions to get things done. Yeah, we covered some of the basics. All right. Type is a kind of label that every expression has. It tells us in which category of things that expression fits. The expression true is a boolean. The expression hello is a string, etc. All right. Now we will use GHCI to examine the types of some expressions. We will do that by using the :t command, right, which, followed by any valid expression, tells us its type. Let's give it a whirl, right? So, T5, that's a number. Where does the PP come from? Actually, let's do it like he does it, yeah. This is a character. Yeah. A is a character, I guess. I don't remember what the double colon was for, what that means. Right. T true. I mean, I don't have to write it out. We can see it right here. T is a character. A is a character. Oh, actually, before he does it, I'm curious how it will behave when we get a string. Oh, yeah. A list of characters. Nice. I like that. A list of characters. P is a placeholder. It can be any numeric type. Oh, right. We don't know if it's a float or an integer. So how can we make sure to get an integer? We could do 5.5 and that would be fractional, but it's still a placeholder. I'm confused. It can be any numeric type. I guess we will get into it. We will get into it. Right. Yeah, that's a boolean. That's a list of characters, otherwise known as a string in a lot of other languages. Right, this is a... Oh. T true A. Oh, I'm surprised that it doesn't say that... Well, it's kind of implied. Yeah, it's a tuple with a boolean and a character. So you just need to know that this is a list, this is a tuple. Right. We don't have to write out the names, I suppose. Just like we might not have to write out integer, we don't have to call it an integer, maybe. And... Oh, right, type for... Yeah, this is a boolean, because this expression evaluates to true. Yeah. These things, writing this and writing this is equivalent. Yeah. Yeah, right? We can do this. Or... right. These are all equivalents, like in maths, right? We could do... No, wait. We would have to... Yeah, we would have to do order of operations, right? There we go. That is equals to false. I wonder if we can do that, by the way. Let's try it out. Yeah, it should be fine. This should be completely fine. Yeah, it becomes true. Because it's true, yeah, indeed. Aaron Sierra says, when you want to have a variable, for example, a counter that counts how many times a loop has run, then what do you do if it only has functions? Right? You probably do it recursively, Aaron Zero. Yeah. You do it recursively, that in the end of your loop, you call your loop again with a new variable instead of changing a variable, right? Yeah, and you just do it recursively, so calling the same function over and over and over again with a new variable. And Sarah says the not changing any variable does not make sense to me. Yeah, that's one of the big ones for me as well. That's complicated, yeah. Colgate InnoTab says there are no loops in Haskell. Right, no loops? Oof. Yeah, because it's lazy. Aaron Sarah says, I'm out of here. Wait, because of no loops? Besides loops, just everything like, I don't know, storing someone's age. How do you do that in a function? Oh man, storing someone's age. One way of doing it is, I mean, we will get to a better one. I remember we did it this way, right? We say that John, and he is 42 years of age. Yeah. Whoops. Oh, there we go. And that would be one way of doing it. Or actually, we don't even need to do that. This is just if we want to have, yeah, if we want to have multiple people, right? If we want to have Sarah, who is 69 years old, right? If we want to have multiple people, that is what it would have to be look like. A list of tuples. But if we just want to have one person and we want one person's age, boom, 42. There we go. I have no idea what you just did. Right, this is a tuple. It's like a list, but... Right. Where's the variable? Oh, the function, alright. The variable, I mean, we can call the variable A. Right? And what do we want to do? We want to... right. What do we want to do? A function. Right. Let's call... how old we call the function, alright? How old? And then we do... fuck, how do we do that? Right. How old... v, right? We need a variable. And then we say that... fuck, I don't remember that. How do we take the second thing again? Oh, right. We do... was it just like this? Second? From A. Can we do it like that? SND. Oh, there we go. There we go. And there we have it. This is a function where we call... Actually, let's try that, see if it works. Now, since we had to try something. Load. Wait, no? Why not? Oh, wait. This was how we do it. Oops. That's not okay. All right. And let's not be liars. There we go. And then we do how old... 42. There we go. That's not a mathematical function, though. No. It's like, right? It's more like. I didn't say it was a mathematical function. I said it was like a math. It's similar. Sorry, that was my bad. It's similar to a mathematical function in its structure. It's the idea of how you make a function comes from how you make a mathematical function instead of the how you make it in the imperative, the normal, the regular programming languages, right? It's a different approach how to make functions. That's why it's called functional programming language. So it's its own kind of thing. Nodonor asks, how do you monad? Oh, I don't know. Don't know. What you did is similar to methods in Java. Yeah, right? It is very similar. But the attitude and the approach behind the scenes, what's going on, is where they try to take the methods from Java, but they try to make it more like the mathematical functions, right? Because of using a logical language, the attitude, right? The idea is that logical languages are superior. Therefore, we try to make our language more and more similar to a logical language. We'll get in on tabs as monads comes later. Thought it was just all monads. Monads all the way down, right? Yeah, I agree, Nodrunner, yeah. And Sarah says you called how old V? What happened to the V if it's not used? Right? V is just that it takes a variable, right? I don't know how you do it in Java, but right, when you do a function, right, in Python, you define how old, and then you type V, and then you return. That's how it would look, right? So this is the V, right? Like when I call it in Python, I would do how old A. Oh, no. Just like that, right? This is the Python way to do... These are equivalent, right? This is the... yeah. This is the Haskell function, and this is the Python function. Right? If we don't call anything, right? If I don't call anything, right? If I just do how old, we get an error, right? Maybe you haven't applied a function to enough arguments. Yeah. We forgot to add in the argument, and that's the argument. We used this as an argument. Nodrunner says, oh, I missed this. Oh, what is this? Guess I'm trying Wayland again. I actually was thinking yesterday about trying Wayland again. NVIDIA Linux beta driver released with GBM. I'm guessing GBM is Wayland. What's exciting with the NVIDIA beta release is GBM API support. After years of waiting and NVIDIA wanting to pursue an alternative API instead of years... Alright. Finally adopting the generic buffer manager API. Alright, this greatly enhances the Wayland support for NVIDIA's proprietary driver stack and makes it compatible with a lot more Wayland software. Nice. For example, the likes of Sway should now run fine with this new driver. Ooh, that makes me happy. Yeah, I'll try on my other computer in a month or something. When people have worked out the kinks, I'll try it out. Sway again. I was actually considering switching this over to Sway as well, because I am looking forward to that. yesterday I was doing some things where I kind of needed some more Xorg knowledge, but I just feel that I don't want to dig into X. I just don't want to, because it's gonna be replaced. I would rather dig into Wayland. Hold on, it has been almost a month since this came out. Well, I'll wait 2 extra months then, I suppose. Right. Chapter 12 and 13. Maybe we will get to chapter 12 and 13 and learn about monads. Right. But this all makes sense, right? We check the different types of what we have. Right. Here we see that doing :type on an expression prints out the expression followed by and its type. Here we go. Has a type of. That's double colon. Has a type of. This has a type of bool. Not is a type of, but it has a type of. Node says Sway uses something called WL roots. Yep. And all of the other window managers do too. Yeah, I remember hearing something about that. Yeah. Wasn't that the whole point with W roots? They wanted to make a framework for people to build window managers on top of. Wayland roots. I mean, it's all there in the name. And if I remember correctly, Wayland roots, right? The people who were working on Sway, like there's a big overlap. People helping each other out, maybe. Banana Waffle Monkey says, oh, monads. It's a different type of monads, though, Banana Waffle Monkey. Different type. Right. Explicit types are always denoted with the first letter in capital case. Right. Explicit types are always denoted with the... Oh yeah, they have a capital bool. Right. So what is a tuple and a list? Are those implicit types? It is not hard to conclude that it stands for character. Yeah, true is a type of bool. Yeah, that makes sense. But what's this? Examining the type of hello yields a list of characters. Yeah. The square brackets denotes a list, so we read it as being a list of characters. Yes, indeed. Unlike lists, each tuple length has its own type. So the expression of true A has a type of tuple of bool character. Oh, right. That's the thing with tuples, right? Because they are defined by their contents. Yeah, it's their own kind of type. Yeah, so a list is always a list of a specific type. Tokens of a type, yeah. While a tuple, you have to restrict the number of items because the tuple is kind of defined by itself. No, says, yeah, my point is that if Sway doesn't work, none of the alternatives will work either. Yeah, but, I mean, I'm gonna be using Sway either way because I have fallen in love with i3 and I don't think, something tells me that I will probably, I mean, I'll try some other stuff out, but I do love i3, so doing it the Sway way like that. But I would also assume that as time moves on, there is gonna be people who don't like the Sway way or the WL roots way and will do their own framework, right? Their own roots. It just hasn't happened yet, but with enough time, probably. Colgatino says, nah, Haskell implemented metaphysical monads, Kappa. I don't believe you, I know. Node says, I kinda wish Nix was more different from Haskell, because now I'm getting them confused in my brain. I mean, I guess we will get into the differences soon enough. I mean, so far we could argue that there has been a lot of similarities with other languages as well, right? Oh, they have booleans, right? The overlap is, you can see them as a benefit, not a con. Yeah, it's a benefit that they overlap because that means you know what you learn and what not to learn. I don't know. Not says i3 is pretty great. Yep, love i3. I was changing my other computer yesterday to only use a mouse and not use the keyboard. And first I was like, oh, I gotta start looking for another window manager. And then I was like, no, why would I? i3 is pretty great, so I just did it within i3 instead. Yeah, I made i3 into a stacking window manager? Floating. No, floating would be the i3 naming convention. Yeah, I made it into a floating window manager. I made all the windows be floating. Still haven't fixed a way to flip between the workspaces. I gotta do that, but I think it's pretty easy, probably. No, says I did the same thing with i3 on my tablet. I made it so it was usable with a touchscreen. Amazing. Amazing. That sounds great, yeah. Alright, we were at tuples. Yeah, so the expression of, yeah, tuples are kind of tuples, yeah. But whereas expressions such as ABC would have the type character. Exactly. A tuple of 3 characters. That is the type. Yeah, this is a tuple of 3 characters. This is a tuple of a boolean and a character. Or a triple. And 4 equals 5 is a boolean. Or equals 5, yeah. That's because this checks for equality. Isn't this always a boolean when you do this? A boolean operator, whatever. But when you do an expression with this function, infix function, you will always get a boolean, yeah. That's because, well... Alright, that's not an expression, that's just a function. Then built-in function? Maybe it's a special case. Note says there was a bar that you could flip out with a gesture, and then it had shortcuts I could just hit with my thumb. Oh, nice. What did you use as a bar that you flipped out? I just took tint 2 because that's the one I remember, but maybe there is a better one. Bar with shortcuts. Actually, I was quite happy with tint 2. Wait, I need to do it this way? Is that an apostrophe? No. 6. Like that? No? Not only used tint 2 2. 2 2 2 2 2 2 2 2 2 2 2 2. Toot a horn? I don't know. Oh, here we go. Functions also have types. When writing our own functions, we can choose to give them an explicit type declaration. Alright, we're getting to it. So many times I'm jumping the gun. Jumping the gun indeed. And that's super confusing. Colgating on tap. HAB equals to A. Well, I guess we're getting to it right now. Yeah. This is generally considered to be good practice, except when writing very short functions. From here on, we'll give all the functions that we make a type declarations. Nice. I've been waiting on this, I think. Yeah. Remember the list comprehensions we made previously that filters a string so that only caps remain? I remember, yeah. Here's how it looks with a type declaration. Oh, right. Alright. Remove non-uppercase. It's a list of characters and it returns... Wait. Alright. Right, remove non-uppercase. It takes a string and it returns a string, right? Right, it has a... No, it has a type of... A list of characters to a list of characters. What does this mean again? Meaning that it maps from a string to a string. Oh, it maps. Have we learned about maps? Did I skip that? Oh, that is how you get the type of the double equal sign. So if I just do HAB equals a... oh, shit. And then we do... Yeah, we hack through to get it. There it is. EQ. Checking for equality. Right, let's keep going. Meaning that it maps from a string to a string. Right. Go from a string to another string. That's because it takes one string as a parameter and returns another as a result. Yeah, so this is input, output, kinda. The list of characters is synonymous with string, so it's clearer if we write remove non-uppercase, string to string. I disagree. I don't like this, right? If you're calling it a list of characters, then keep calling it a list of characters. Don't call it a string. That increases complexity and confusion. Let's call it a list of characters. Actually, it's fine. It's fine. Either way, I guess. EQ is equatable. Two parameters of the same equatable type and returns a boolean. Oh, right. It takes two... Oh, okay. It takes two equatable things, right? Because we cannot... Right. A and B has to be equatable, so that's... It's implied. It knows that they need to be... That's the type inference, right? Type inference. Two things that are equatable. It takes that and... What did you say? Two parameters. Yeah. And it returns a boolean. Right, which is the parameter... Wait. Oh, yeah, it takes... Yeah, it takes a variable of that type and another variable of that type, and then it returns the boolean. This is like a... This is very confusing why this is here. Right, because this kind of... To me, it seems like this is B... Wait. No. A... B, and then we return a boolean where we check for equality. Yeah, I don't know if I like how this is done, right? It's not super clear what's going on here. It's not friendly at all. Right, I can't figure it out just by looking at it. Alright. Right, because it kind of looks like, yeah, we take one input and one output, but this is not it, yeah. This is input, and this is output. So why do we have the same arrow here and here? Sucks. And here we have an equal sign before the arrow. Oh man. We'll get to it. Jumping the gun again, I guess. Yeah. Right, the list of characters is a string, so it's clearer if we define it as string in, string out. What was the double colon again? Alright, has type of. Right. Our function has the type of. Oh, so this is... Yeah. Yeah, this is like in C, we write... Right, we do this. Right, so this thing, remove uppercase, this is equivalent to writing int. It's just Haskell is way more involved in what a type is, right? It's way more involved. Oops. Colgatina tab says because it's a function that takes equatable type and returns a function that takes... Right. Yeah. Okay, so it's actually a function that takes an equatable type and returns a function that takes the same equatable type and returns a boolean. Right, I feel that that's a tiny problem I have with Haskell, right? It's the same as we said before, right? What was it? This and this is equivalent, right? So Haskell, it feels like Haskell wants to write things this way instead of this way. And I feel if Haskell is doing it this way, why don't we type it out this way, right? Why do we write the function like this instead of how it's actually done, right? It feels like under the hood Haskell does things one way, and we're supposed to know how Haskell does it under the hood, but our syntax is not... Right? Like you say, right? Multi-parameter functions are just a human way of thinking of it. Isn't the human way of thinking of it just more confusing? Nordrunner says, I'm lost. I thought this was a tutorial for Fortran 77. I don't even know what that is. Isn't that a super old language? Can you do if statements? We can indeed. Yeah, we can, and you have to. I remember from the if statements, we cannot just do if. It has to be if something, and then. Right, you can make a function like this, but another thing with the functional program is that every function has to return something. So there has to be if then. No, if else. No, wait. If else, I mean. Yeah, if, then, else. There we go. Here we go. Yeah. You have to do an if statement like this. If whatever, then do this. Otherwise do this thing, because you have to return something. Because everything is a function. I think that's the significant difference on if-else statements, indeed, yeah. Right. Like it feels like Haskell thinks that this is clearer, but I kind of think that this is clearer. Right, we didn't have to give this function a type declaration because the compiler can infer it by itself that it is a function from a string to a string, but we did it anyway. But how do we write out that type of a function that takes several parameters? Yes, here we go. Here is a simple function that takes 3 integers and adds them together. Add 3. Right. I feel like I'm jumping the gun again, yeah. Int. We add that into this int, and we add it into this int, and right, yeah. Exactly. Just what we did, but different, right? The parameters are separated with the arrow sign, and there is no special distinction between the parameters and the return type. The return type is the last one though, right? The return type is the last item in the declaration, and the parameters are the first 3. Later on we'll see why they're all just separated with an arrow instead of having some more explicit distinction between the return types and the parameters like int or something. But we did notice this though, right? Oh no, this is something new. This here just points out, this is like the equal arrow thing. That just describes the variable, right? That the variable that we take has to be equatable. Yeah. And Sarah eats licorice. Oh, gross. How can you do this? Oh, just eating my favorite example just like that. Oh yeah, parameter. Terrible with not. I'm terrible with names. Variables or lying program. Yeah, variables are a lying programming things. Only liars use variables. Only liars use variables. Alright. If you want to give your function a type declaration but are unsure as to what it should be, you can always just write the function without it and then check. Check for it. Functions are expressions too, so the type works on them without a problem. I think it's when you're learning a language like this, it's good practice. So we should, in all functions that we do, we should do type declarations, because type declarations helps us understand the language and it helps us understand what we are doing. I think. Colgate on tap says that a politician's truths are also varies. They do indeed, yeah. Aaron Sarah says it's not lying, it's being open to change. Nice. I like that. Wait. NodeRunner found the solution to all my problems. All my problems are solved right now. It's just, boom. Did you buy me a house? Is that what happened, NodeRunner? Right. No code. Right. What is this? No code. No code is the best way to write secure and reliable applications. Write nothing. Deploy nowhere. Getting started? Start by not writing any code. This is just an example application, but imagine it doing anything you want. Adding new features is easy too. The possibilities are endless. Building the application. Now that you have not done anything, it is time to build your application. Boom, this is how you do that. Yep, that's it. You should see the following output. There you go. Right. How to do the deploying. While you still have not done anything, it is time to deploy your application. By running the following command, you can deploy your application absolutely nowhere. It is that simple, and when it comes time to scale the application, all you have to do is, I know, right? Contributing, you don't. Oh man, this was amazing. I mean, yeah, this is the solution to all my problems. 447 pull requests. Someone did not read the instructions, I think. And some people had issues with it. 3,500 issues. Where's all the code? Repository contains files. That's a problem, yeah. Learned a lot. Nice. Amazing. No code is too complex. Yeah, we need to make it easier. Is no code sentient yet? Oh man. I think this is my favorite thing I've seen on GitHub, like forever. It's amazing. Aaron Zero says change is inevitable. Right, but there's a difference, Aaron Zero, right? Politicians can say something and then change their mind. But oftentimes they say things that are not, it's a version of not being truthful, right? Where what they say are intentionally open to interpretation. I would actually say a problem with a lot of politicians is that they are not being open to change, right? How many times do you hear a politician say, "Oh, I've changed my mind"? How many times have you heard that? I haven't heard it many times. That would be a problem, yeah. Olgi Taps says maybe they just go through mental growth right after the elections. Yeah, that's probably what happens. Probably what happens. Yeah, they changed their mind after the elections. It's funny how that correlation happens. And Zero majestically sucks on licorice. Right, I'm trying to image how majestically sucking looks like. But I don't know if that's safe for work, so maybe we should leave it at that. Alright, common types. Integer. Used for whole numbers. 7 can be an int, but 7.2 is not an integer. An integer is bounded, which means that it has a minimum and a maximum value, right? Usually on 32-bit machines, the maximum possible int is these numbers, and the minimum is the same, yeah. Integer stands for also integer. Oh, is this a 64-bit? No, the main difference is that it's not bounded, so it can be used to it can represent really, really, really big numbers. I mean, really big, right? Int, however, is more efficient. Like, space is big. Just since it's lazy, an integer can be infinite, right? Does that work? Factorial. Right, what is this? Takes an integer and gets an integer. Wait, factorial. Alright, the product of 1 into, wait, n? Oh, right. Oh yeah, the factorial is when you multiply all the numbers together. Yeah. That's a way to create this is just a very easy way to create a big number, right? That you take 1 times 2 times 3 times 4 times 5 times 6 times 7 and up to wherever you want to go, yeah. Factorial of 50. Yeah, that's a very big number. Way bigger than an int. Wouldn't it be better? I'm right? Wouldn't it be better to have an int and then into an integer? Maybe. Right, float is a real floating point with single precision. Right, with single precision? What does that mean? I don't know. Right, so circumference takes a float and we get a float. Right. Oh, right, radio. We get the radial and we multiply it by pi and 2, and then we get the circumference. That's mathematical. Here we go. That's a mathematical function. First one. It kind of looks like I'm not a mathematician, but that's kind of what you do, right? Right. Double is a real floating point with double the precision. Yeah, double is just bigger, yeah. It's the bigger version of the float. More precision. Aaron Sarah says that the CPU has a component called the arithmetic unit that specifically deals with large floating point numbers. It's very nice. And I'm assuming that we call that when using doubles, if it's specifically done for that. Right, Boolean is a Boolean type. It can have two values, true and false. Yep. Character, it's denoted by single quotes. List of characters is a string, we know that. Yeah. This is nothing new, right? This is the same almost everywhere. Not everybody cares about floats and doubles. Not everybody cares about int and integers, but behind the scenes they are... There is a difference, yeah. Tuples are types, but they are dependent on their length as well as the types of their components, yeah. So there's theoretically an infinite number of tuple types, yeah, indeed, yeah. Which is too many to cover in this tutorial. Not that the empty tuple is also a type which can only have a single value, the tuple. Oh, it's called the arithmetic logic unit. Arithmetic logic unit. To type variables. Wait. Didn't Colgate-Inotab says that only liars talk about variables? What do you think is the type of the head function? Because head... Oh man. The head function? I mean, we were talking about majestically sucking before, didn't we? Because head takes a list of any type and returns the first element. So what could it be? Let's check. Right, right. This is where we have a variable because it can take a list of anything and return the thing. That's why we see a here. It's a little bit confusing that I used a in my function and thinking that why is a here? But a is just... A is a placeholder, right? It's a placeholder for any of these things, right? You can have a list of any of these things. You can have a list of ints, you can have a list of integers, you can have a list of floats, you can have a list of doubles or bools or characters. And the head returns the first one. So the tail would return a list of A's. Colgate-Inotab says, I think unknown would be a better name here as they don't really vary. Yeah, I mean, unknown would be a long word And now that would be confusing as well. Maybe A is a good choice. Right. What is this A? Is it a type? Remember that we previously stated that types are written in capital case. So it can't exactly be a type because it's not in capital case. It's actually a type variable. That means that A can be of any type. This means much like... maybe it should have had a V then, right? It's a variable. Or TV. This is much like generics in other languages. Only in Haskell it's much more powerful because it allows us to easily write very general functions if they don't use any specific behavior of the types in them. Indeed, functions that have type variables are called polymorphic. Polymorphic functions. Actually, that's a pretty good name for it. Yeah, polymorphic functions. The type declaration of head states that it takes a list of any type and returns one element of that type. Exactly. I guess A is just fine. Although type variables can have names longer than one character, we usually give them names of A, B, C, D. Oh, right. If I would have... yeah, that actually makes sense, right? If I had multiple... if I had multiple variables, multiple parameters, yeah. Multiple parameters that were variable, where you could change them all around. It would probably be A, B, C, and so on and so forth. Aaron Sarah says, can't you say, for example, A equal to 1, and when you want to change it to say A equal to 2, or A equals to A plus 1? Nope, that is not allowed in Haskell. That is not allowed because that makes you a liar, right? Haskell thinks that, well, if you're doing that, you're a liar. Right. Okay, Tinotab says you don't change them in functional languages. Yeah, you just don't. You don't change the variables. A equals to A plus 1 is a function that has infinite recursion. Yeah, that wouldn't... yeah, that wouldn't... we would end up in an infinite loop, but you don't do loops. You do recursion, yeah. That would definitely be... would become some infinite. Yeah, because you don't set A to A. It just... it calls A over and over and over and over and over and over again, yeah. No conditions. You would have to have an if statement or an end to it. Right. Make it in a list comprehension. Yeah. We could do it in a list comprehension. All right. Let's practice a list comprehension. Right. Right. We do A plus 1. And A is what? It's an infinite list, right? Yeah. A is an infinite list where we take... that's an infinite list. But we add a predicate that A has to be smaller, smaller than 42, 43. Wait. What did I do wrong? Oh! That doesn't work, because it still kept infinitely going, checking 43, 44, well... yeah, it checked 44, 45, 46, like it kept going infinitely, recursively. So, we have to make an if statement, yeah. The predicate doesn't work. We would have to... if... A is smaller than 43. Wait. Do I have to write then? Wait. Shit, I don't remember the syntax. Else... Oh shit, I don't remember the syntax. Oh, take. Wait. Oh, right, but then we're doing it here. Yeah. Right, we can just take... Oh shit. That would stop it, right? No, wait. Oh, where did this come from? And that's one way of doing it. Or if statement, but I don't remember the if statement. You can do it outside of parentheses. Wait, if statements are rarely used. There are better ways to use conditions in Haskell. Oh, nice. Like, it's better to just take 42 or something like that. Why are the other ways better? I kind of like if statements. What's wrong with them? Chapter 4 has more about control structures. Alright, so we're jumping ahead again. And... getting to lunch. Man, should we take a break here? No, let's finish this bit. Alright, remember FST? No. It returns the first component of a pair. Oh yeah, I remember that. It takes a tuple of a... yeah, there we go. There's the B. Because they don't have to be of the same type. A and B don't have to be on the same type. So that's where the B shows up. But it takes the A. Just like second would take the B. Which would be... Aaron Sear says, I don't understand why you say it's a function. In Haskell, that is a function. Yeah. This is a function. This is how you write a function. Yeah. This is not a... like, you don't set the variable. This is a function. This is how you write a function. Actually, we can... well... it's not the best of functions because it would create an infinite loop or the equivalent to infinite recursion. Yeah. Colgatino tab says because in Haskell it is a function. Yeah, that's like the most basic of functions is like yeah, 1 + 1. There we go. Have you ever heard of Shopify? Asks a node owner. I have not. What is it? How do you make A equal to A + 1? All right. What you do then is that you say that, right, you'd make a function that we take, oh, right. The best way is just to, actually, we can do that. We can just, I think I have an A. Oh. Well, I can cheat. We can say that A is now... in here we can cheat, right? A is now a number. Then I do suck A. Boom. Now I have it. A + 1. Because this is a function successor, it takes A + 1. Or I can just write A + 1. Or I can create a function that I take APO that takes a number and then we take, what is it, n + 1? Oh. And then we do APO A. That's all the ways I can think of doing it. I guess. When you say a is equal to 42, why is that not a function? It is a function. Yeah. Oh, yeah. It's functions all the way down. Yeah. It takes no parameters and returns 42. Yeah, it's a boring function. It's a... That is why I was so confused before by... What did we do again? Yeah, I got so confused by this. Because they're all functions. Yeah. They're all functions. There's functions all the way down. Well, types. I think that, yeah, it's a bit confusing. It's gonna take a while to wrap my head around it, indeed. Alright. Right. Where were we? Alright, we see that first take a tuple and it returns an element which is the same of the same type as the pair's first component. Yeah, that is why we can use first on a pair that contains any two types. Yeah. Note that just because A and B are different type variables, they don't have to be different type variables. It just states that the first component's type and the return value type are the same exactly. And then we're at type classes, and I think we've been doing enough Haskell for today. Yeah, and it's time for lunch, and we'll go in on type classes. That's what we start with tomorrow, yeah.